Ever wondered how developers collaborate on a project? One of the secrets lies in a tool called Git. Git isn't just a four-letter word. It's a game changer in the world of coding. It's the cornerstone of many development projects, the silent hero behind seamless collaboration, and the safety net catching any accidental slips in the code. So, what exactly is Git? Git is a distributed version control system. In simpler terms, it's like a time machine for your code. It keeps track of every change, every addition, every line of code deleted. It's like having a rewind button for your project, allowing you to go back to any version of your code at any given time. Beyond just keeping track of changes, Git enables multiple developers to work on the same project simultaneously, without stepping on each other's toes. It's the peacekeeper in the battlefield of code, ensuring harmony among developers. Now you might be wondering how to use Git. Fear not, you'll understand it by the end of this video. To get started with Git, you need to install it on your computer. This is a straightforward process, regardless of your operating system. If you're using a Mac, you can install Git via the terminal with a simple command: brew install Git. For Windows users, you can download the official Git client from the Git website and follow the installation instructions. Linux users can use their package manager such as apt or yum to install Git. Once you've installed Git, it's time to initiate your first Git repository. This is the database where Git stores the snapshots it makes of your project. To start a new repository, navigate to your project's directory in the terminal and type Git in it. This command creates a new subdirectory named egit that contains all of your necessary repository files, a Git repository skeleton. Now, let's talk about what a Git directory is. This is the most important part of Git, and it's what makes it a version control system. The Git directory is where Git stores the metadata and object database for your project. It's the area that gets copied when you clone a repository from another computer. The Git directory is the heart of your project. It's where Git keeps track of all the changes you make, the different versions of your project, and the entire history of your work. It's like a time machine for your project, allowing you to go back in time to any version of any file in your project. Remember, Git is more than just a tool. It's a philosophy of how to manage your code. It encourages you to commit changes often, keep your projects organized, and work efficiently with others. It's an essential tool for any developer, and mastering it will make your coding life much easier. Now that you have Git installed and a new repository initiated, you're ready to start tracking your project. The world of Git awaits you, so let's dive in and explore what else you can do with this powerful tool. Understanding Git commands is like learning a new language, but don't worry, it's not as complicated as it sounds. Let's start with the first command, git add. This command is your first step towards tracking changes. When you type git add, followed by the name of a file, you are telling Git to pay attention to this file. It's like pointing a spotlight on a performer on a stage. But what happens after the spotlight is on? That's where git commit comes in. Consider git commit as the director who takes a snapshot of the stage. This snapshot is a record of all changes that have been added using git add. Typically, you'd follow git commit with a message, enclosed in quotation marks, describing what changes the snapshot includes. This is like the director taking notes about the scene. Now imagine you're the director, and you've lost track of which scenes you've captured. This is where git status becomes handy. By typing git status, you're asking Git to tell you what's going on. Git will respond by listing files with changes that are staged for the next commit, and files with changes that are not staged yet. It's like having a stage manager who keeps track of every scene. Finally, let's talk about git log. This command is like a script of your project's history. When you type git log, Git presents a list of all the commits you've made in reverse chronological order. Each entry includes the commit ID, the author, and the commit message. It's your personal time machine, allowing you to revisit any point in your project's history. So there you have it: git add, git commit, git status, and git log. 4 simple commands that form the core of Git's functionality. Each of them plays a unique role, and together they provide a robust system for tracking changes in your project. With these basic commands, you can start tracking changes in your project. In Git, branches are a crucial part of the workflow. They're like parallel universes where different versions of your project live. Imagine them as separate workspaces where you can tweak, experiment, and develop features without disturbing the main code. Why do we need branches? Well, they help keep your work organized and isolated. Say, if you're working on a new feature, you can create a branch specifically for that. This way, the main code, often referred to as the master branch, remains unaffected. It's like having your own little sandbox to play in without worrying about messing up the entire playground. So, how do we create a branch? It's simple. The command git branch followed by the name of your new branch does the trick. For example, git branch feature X creates a new branch called feature X. But creating a new branch doesn't automatically take you there. You remain in your current branch until you decide to switch. That's where the git checkout command comes in. To switch to feature X, you'd use git checkout feature X. And voila, you're now in your new branch, ready to work on feature X. Now let's talk about merging. So you've finished working on feature X, and it's time to incorporate these changes into the master branch. That's where merging comes into play. With the git merge command, you can combine the changes made in your branch with the master branch. It's like taking the toys you've been playing with in your sandbox and putting them back into the main playground for everyone to use. But remember, merging should be done carefully. Conflicts can occur if the same part of the code has been modified differently in your branch and the branch you're merging with. Git is smart, but it's not a mind reader. It's up to you to resolve these conflicts and ensure a smooth merge. Branching and merging are what makes Git a powerful tool for collaboration. They allow multiple people to work on a project simultaneously, each in their own universe, yet capable of sharing and integrating their work seamlessly. It's like a well-oiled machine where every part functions independently, yet contributes to the whole. Working with remote repositories allows you to collaborate with others on a project. Let's dive into remote repositories, the unsung heroes of collaborative coding. In the simplest terms, a remote repository is a Git repository hosted on the internet or some other network. It's your project's home away from home, a place where your project lives and breathes in the wild. It's like a public library for your code, where others can check out what you're working on, contribute their ideas, and help build something amazing. Now, you might ask, how do I get my local work onto this remote repository? Well, that's where cloning comes into play. Cloning is like creating a local copy of the remote repository on your computer. It's as simple as running the command git clone, followed by the URL of the repository. This command copies all the files, history, and branches from the remote repository to your local machine. So you've cloned your repository, made some changes, and now you're ready to send those changes back to the remote repository. This is where git push comes in. Think of it as your way of saying, hey, I've made some cool changes. Check them out. With a simple git push, your changes are sent from your local repository to the remote one, ready for others to see and use. But what if someone else has made changes to the remote repository while you were working? You wouldn't want to miss out on those, right? Absolutely not. And that's where git pull comes into play. It's like saying, hey, if there's anything new up there, bring it down here. Running git pull fetches any new changes from the remote repository and merges them into your current local working branch. With the understanding of remote repositories, you're now ready to collaborate on projects with other developers. So go forth and code collaboratively. Remember, every great project starts with a single git push. So that's a basic rundown of how to use Git. We've delved into the fascinating world of Git, starting from its definition. We've uncovered what Git is, a powerful tool that aids developers in tracking changes in source code during software development. We walked through the process of installing and initiating Git, a straightforward task that sets the stage for the rest of your Git journey. We also dived into the heart of Git, exploring the basic commands that make it tick. From creating new repositories, committing changes, to checking the status of your work, these commands are the lifeblood of your interaction with Git. Furthermore, we ventured into the realm of branching and merging, a crucial aspect of Git that allows for effective collaboration and version control. And finally, we crossed the bridge into the territory of remote repositories, connecting our local work to the global Git network. Remember, mastering Git takes practice. Keep experimenting, and soon Git will become an indispensable part of your development toolkit.